So the first question is, how do linked lists interact with memory? So linked lists are stored in the heap instead of the stack. This is due to the fact that the linked list, as opposed to a array, doesn't get a block of memory. Instead, it gets sections of memories and it points to each. So if we have a array, and let's say this is the memory, an array of like size 9 will get 9 blocks of memory. Let's just say 2, 3. So it'll like, in the static memory, it'll store each of the blocks already based on the size. For a linked list, however, the memory it uses is in the heap. So if we have a linked list, and as we're inserting, let's say we insert 3 nodes, it's just gonna randomly at different points make the 3 nodes that are gonna link each other through pointers. The benefits and disadvantages of using a linked list. So a linked list is, overall, it uses more time, and that's because of traversing. So if we have a linked list, and if we want to get to this last node, it's gonna have to traverse all the way through, as opposed to an array, which, if this is an array, it already has the blocks next to each other in memory, so you can just access it straight up like this. But in a linked list, it'll have to point to different spots in the memory, like it showed here, so it could take a longer time. So another disadvantage of a linked list is the fact that it uses more memory. So because in a linked list we use pointers to store the address for the next node, this uses more memory. Now moving on to the advantages of a linked list. Because a linked list is a dynamic arrangement, we do not have to specify a size like we do in an array, so it is more efficient in that sense. So in an array, as you can see right here, if we initialize size 9, it'll get those sizes, those indexes in the memory. But in a linked list, we do not have to specify a size. We can just keep inserting and deleting. And because of this allocation and deallocation method, a linked list does not waste as much memory. So setting up a class and a node structure in a linked list. So a node, a structure called node, is going to have the values inside of a node. So we can have an integer value, and then we can have a pointer to the next node. So something like this. As for setting up the class, we can have a class called list. And in this list, we can have private and public functions. So in a private function would include the head of the type node, because a head is a pointer to the first node in the linked list. So obviously it's going to have the value and then the next pointer as well. And then in the public function, we're going to have, we can have a get, or at first we're going to have a constructor that will initially set the head equal to null. And also we can have an isEmpty function that will return true if if the list is empty. And then we can have some addition functions that will insert the nodes, so we can do it at the end or the beginning. Let's just say at end. That'll take like an integer value, because in the node we have the value that it's going to fill in. And then we can have a delete as well. So we can delete from the beginning or the end, doesn't really matter, whichever one we choose. So delete at end. And a print function that's going to print the linked list. So a head pointer will point to the first node in the linked list. And this is why like linked lists are also pretty efficient in their implementation, is because it's just like an array. This would be the first index and it can just keep track of all of the rest of the nodes. And that's really all there is to the head pointer. It just keeps track of the first node so that we can traverse through the list, perform different functions. And then as for the private public functions, we already mentioned right here. In the private, we're gonna have the head. In the public, we're just gonna have the functions to insert, delete, and then set the head equal to null and then print. So a singly linked list is pretty much this. All it does is it starts at the head and it links each node like this. I know we haven't like went over doubly linked lists, but I do have somewhat of understanding of a doubly linked list. A doubly linked list just has so it keeps track of the previous node as well. So as opposed to just having a a next pointer, it'll have a previous one as well. In a singly, all it is just keeps track in a straight line of the next pointers or the next nodes. And then a circular linked list, I would assume, is that it links the last node to the beginning, so it'll be like a circle. Now I'll just show the code. This is my code for the Fun Friday linked list. So this is my main file. It just includes the LinkedList.h and then makes a object of factory build, which is our class, and then inserts at end and then prints, removes car from position, and then prints again. So basically the insert at end, it'll insert in the linked list in this order. So Tesla, Ford, Mustang, Nissan GT, and Subaru WRX. And then it's going to print and then remove car from position. If we pick the position to be 1, it's going to remove from the end. So this will be 1, so it'll remove Subaru WRX. If we pick 2, it'll remove Nissan GT. Instead of working from the front, it'll work from the back or the end. So moving on to my LinkedList.h file. Here's our structure called class. It'll have the model and the price and then the pointer to the next car. So basically the structured car will just have all the attributes that we would have in each node of the linked list. Moving on to our class factory build. So we're gonna have a private variable called head that will keep track of the first car or the first node in the linked list. We're gonna have our constructor that will initially set the head equal to null. And then right here, I didn't really use this function, but a get head function would be useful if we were to print recursively. I didn't do that though, but it would be useful. Then we have the insert at end function that obviously has the model and the price and then inserts that car to the end of the linked list. And then the remove function that we talked about, and then the print. So moving on to the LinkedList.cpp file, here's our insert at end function that takes the model and the price. It'll make a new car and fill in its model, fill in its price that we just got from the user. And it's going to check if the head is equal to null. So this is an edge case. So if head is equal to null, meaning the list is empty, we're going to make this new car equal to the first node. So make it the head. And then we're going to return. Else what we're going to do is make a new car called temp2. And initially we're going to start it at the beginning of the list, so the head. And then we're going to traverse until we're at the end. So we're at the last car. Temp2 is equal to the last car in this case. And what's going to happen is this temp2 is not going to be the last car anymore, because since we're inserting at the end, this temp will be the last car. So basically temp2 is now going to point to temp, so it'll become the second to last car, and temp, as you can see right here, is already pointing to null, so it'll become the last car. Moving on to our remove car from position function. So here's the edge case. If head is equal to null, we're going to return null because the list is empty. Else what we're going to do is make 2 nodes of the structured car called fast and slow. We're going to start them both at head initially. And basically what we're going to do is in this for loop, fast will basically become the position from the start that we want to delete. So and basically what we're going to do is we're going to check if at that node, if it's null, meaning there's nothing there, what we're going to do is we're going to make fast equal to the head, and then we're going to make head equal to the second in line, and then we're going to delete the previous head. So basically it's like a wraparound. So if fast is equal to null, meaning there's nothing in fast, basically we're going to wrap around to the front of the linked list, and we're going to delete the initial head and make the new head equal to the second in line initially. Else if fast actually does have something, it actually does have a car. Then we're going to traverse through the list, and we're going to make fast equal to the last car, and slow will also traverse. So basically what we're going to do is if we have if we have Tesla, Mustang, and a GT, and let's say we want to delete at index 2, so Mustang, right, working from the end, basically fast will become GT and slow will become one behind what we want to delete. So slow will become Tesla. In this line of code, fast will now become what slow is pointing to. So fast will become what we want to delete, which is the Mustang. And then slow, this line right here, basically is going to point this Tesla straight to the GT, because now we're severing this link from Mustang to GT, and now Tesla will be pointing straight to GT. And then we just print out what we removed and delete the Mustang, or delete whatever we want to delete, and then return the head, so we can obviously print out the new linked list, the altered linked list, pretty much. This is the print function, so we're gonna have the temporary equal the car start temp equal to the head, meaning at the start, and we're gonna traverse through it. At each of the nodes, we're gonna print out the information and then move to the next node or the next car in the list. So now I can run the code and show how it works. So it should print in this order: Tesla, Ford, Mustang, Nissan. As you can see, prints in the right order appending to the end. And then right here we're going to remove at position 1, so it's going to remove Subaru WRX and then print the new list without it. Now let's do 2, so it should remove Nissan GT. Right there, remove Nissan GT and the new list. And just to make sure that our code is perfect, let's pick 3, so it should delete Ford Mustang. So right there, as you can see, remove the Ford Mustang, and here's a new list. So let's just account for the edge case, so meaning if the list is empty. So we haven't inserted anything. Now let's see what happens. As you can see, if the list is empty, it should say list is empty. There we go. And that's all of the code.